Welcome to Stanford Med Story, a new series where we cover a new medical concept and the research being done here at Stanford Department of Medicine to solve some of the world's biggest health challenges. I'm your host, Rebecca Handler, and today we'll be talking with Dr. Olivier Givart, who's working on cancer diagnostics using AI technology. Today we're going to talk about a new tool that you have in development called Sequoia. But to start, I'm wondering if we could really talk about cancer diagnosis as it is right now. What does that look like?
Typically, a piece of tissue from a biopsy or maybe from surgery is analyzed by the pathologist. They put a piece of tissue on a glass slide and they look at it under a microscope. And they use this kind of staining, which is hematoxylin and eosin staining, to look at the cells and the tissues. And this is what is called a whole slide image. And they use this to determine the stage or the grade of the tumor. And that essentially determines subsequent treatment of the patient. So that's kind of like one part of the workflow of how a cancer patient is diagnosed.
And does that involve RNA sequencing and looking at the genomic sequencing of the biopsy of the tumor?
Genomic sequencing is more and more being used. It's when we use RNA sequencing for cancer patients, we essentially get a snapshot of all the different processes and pathways that are active in a tumor or in a cancer sample. And that gives us a lot of information about these processes that you're talking about, inflammation, hypoxia, other types of processes that are relevant for cancer patients. And that can give insight in terms of what drugs to use, but could also give insight in drug discovery. Because if we know what processes are active, we can also design drugs to counteract these processes. It's really a very versatile way of measuring what's going on in the cell and in the tissue. And it gives us a lot of information, both diagnostic, prognostic, but also in the basic science in terms of the basic molecular processes that are ongoing.
And as of right now, as it stands, it is expensive to do genomic sequencing of these samples, and it's time intensive. So what you're working on here is really innovative in the sense that that will hopefully cut down the time and cut down the cost of being able to understand what is going on with a patient's tumor. Can you just describe Sequoia, what it is in simple terms, and how you're using it in cancer diagnostics right now?
This model essentially looks at the image, and then we've built an AI workflow that is based on a foundation model that extracts features from these images. And then using these features, we put those in what is called a transformer. This is very similar to what's done in ChatGPT. And then we can predict up to 20,000 genes, their activity.
So traditionally, you have a biopsy, so a tumor sample that's being taken out, and you're looking at the tissue under a microscope. So it takes a lot of time, and it can be difficult. But what you are doing then is you're looking at the image, you're putting it into this software, and just like with generative AI, you're using that to make predictions. What are we actually looking at predicting through this process?
What we are essentially seeing is that the image is acting as a surrogate of what's going on molecularly. So I also have to admit that we were surprised how good this model worked, in terms of how many genes we can actually predict from the image.
Wow.
For example, in breast cancer, we can predict up to 15,000 genes with very high accuracy and low error. And this essentially tells us that these high-resolution images are essentially hiding, or that there's signals in there that maybe cannot be seen by the human eye, but that a model, like a machine learning model or an AI model, can actually distinguish and can use for prediction.
Why was breast cancer specifically chosen as one of your areas of study?
So in breast cancer, there's a number of commercially available assays that are being used right now to determine treatment of these patients. MammaPrint is one of them. It's based on a number of genes. And that test is being used to determine whether women would get chemotherapy or not, depending on their risk of recurrence. And breast cancer is really one of the main examples right now in the clinic where these assays are being used. So we wanted to show that using Sequoia and the digital prediction of these genes without doing the actual assay can essentially mimic that assay. And then we can only use the AI model to make the prediction instead of actually having to run the molecular test.